Hello, this is the third episode of our video series about decentralized identifiers. Last time we created a few DIDs, but we did that using a remote service and using something that we call internal secret mode, which means that the registrar component, which takes care of DID-specific operations, and the wallet component, which performs key operations, are co-located. And it's important again to emphasize that creating DIDs should be thought of as an abstract process that can take shape in different ways and using different architectures. So today we will take a closer look at what we call client-managed secret mode. In this approach, we still have a client component interacting with a registrar component, but in this time the wallet, which takes care of the key operations, stays on the client side. In other words, we're really separating all the DID-specific operations that are executed by the registrar component from the key operations which stay on the client side. So this means that the registrar component will take care of all the DID method specific functions. It will create payloads, it will construct messages, it will interact with blockchains or web servers or whatever else is needed for a specific DID method. It will do all that except for the key operations, generating keys, signing payloads, all of that will happen on a client side. And we will explore a flow, how a client and the registrar component interact with each other in order to make that happen, which is of course better for decentralization and for really being in control of the identifier. So again, let's take a look at the architecture. In our last video episode, we showed how a client can invoke a registrar component which takes care of communicating with all the different verifiable data registries. And we were using an approach called internal secret mode, where the cryptographic keys that are needed for creating the DID are located in a wallet which is part of the registrar component itself. We discussed how this is not ideal from a decentralization and self-sovereignty perspective. So this time we will use a different approach that we call client-managed secret mode, where a wallet component where key operations take place is part of the client itself. So this means that a client would still invoke a registrar component using more or less the same inputs and outputs, the same interface, and the registrar component will still take care of all the DID method specific communication and messages and so on, but all the key operations will take place on the client side. This means that there's a certain back and forth, a certain communication taking place between client and the registrar. Typically, the client component will invoke the registrar and it will request that a new DID is created. And the registrar component will, for example, come back with a response to the client that says that the client needs to generate a key first. Then the client can call the registrar component again, which this time may return a response to the client, instructing the client to sign a certain payload. And after that, when the client invokes the registrar once again with the signed payload, now the DID may finally get created and returned to the client. In all of this, there's an ongoing process, a state that has to be managed between the client and the registrar, where we use a field called job ID to track this. The advantage of this is that the client can still be implemented in a very generic way, where it does not have to know anything about DID method specific aspects. That is all still being abstracted away by the registrar. However, the client stays in full control of the cryptographic keys. So let's go ahead and create more DIDs again, but this time using this approach. To show this, we once again use our platform godiddy.com, where I've already prepared some of the inputs here for the universal registrar to create a new DID. I already selected a DID method, didIndy. I prepared the DID document with a service endpoint that I want for the new DID, and I chose some options, in this case a network where I want the DID to be created. But this time I will also turn on an additional option which enables client-managed secret mode. If I do not turn on this option and I click on create DID, then everything will happen automatically and very quickly, because the universal registrar service takes care of the key management operations and the DID operations. But if I try to create a DID with this option turned on, what happens is that the request is successful, but the state of the process is not yet finished. It says state action. If I look at the details, then it says action get verification method. What this means is that the universal registrar is now instructing me as a client that the new key pair has to be generated on the client side based on a template, because that is the whole point of client managed secret mode, that the client stays in control of the keys. I will now go ahead and create such a key pair on the client side using my command line, and I can really use any generic cryptographic key management tools that don't need to know anything about DIDs at all. In this demonstration, I will use a generic tool, OpenSSL. I'm going to generate a new ED25519 key pair, write the private and public keys to local files, and I will also extract the public key from those files and encode it in base 58 format. This public key is now something I need to include in my next request to the universal registrar in order to proceed with the DID creation process. So I go back to the user interface where I have the ongoing state, and in the DID document I will now insert a verification method, and I will copy and paste the public key of the ED25519 key pair which I created on the client side. I paste this into the DID document, then I go ahead and submit the next request within this ongoing process, calling again the Universal Registrar API in client managed secret mode. It was again successful, and this time it comes back to me again with a state action, but the action is now sign payload. So this means that there's now a certain payload which the Universal Registrar service is instructing me as the client to sign. So I need to create a signature on the payload before the ongoing DID creation process can finish. I go back to the command line, I take this payload, which is base 64 encoded, I decode that, and I write that to a local file. And then again, as an entirely local process, I execute another OpenSSL command, this time to sign the payload with the private key that I created in the previous step. When I do that, I now obtain the signature which is needed, and with that again I'm going to call the Universal Registrar API, which still keeps track of the state of the ongoing DID creation process. And in my next request I include that signature. In the user interface, I can still see the ongoing process, and in the secret input field, I now insert a response to the signing request, which I received in my previous interaction. I copy my base 64 encoded signature, which I created with my local key pair, paste it here into this input field, and then call the API again. And now it says the state is finished, and the new DID has been created. So I just went through a process that involved multiple steps, multiple interactions between a client and the Universal Registrar service, but all the key operations happened on the client side. Even though this protocol may not be that trivial, it is still completely generic. So the client doesn't have to know whether it creates DID INDI or DID EPSI or DID key or any other DID method. This is a generic universal interface for creating DIDs where all the keys stay on the client side. So today we created a few additional DIDs, and this time we used an interesting architectural approach that we call client managed secret mode. To summarize again, this is a way how the key operations performed on the client side can be cleanly separated from the DID operations performed by a registrar component. The great value of this is that it's possible to build and implement clients that potentially support a lot of different DID methods and networks, but the clients don't have to actually implement any functionality that is DID method specific, because all of that heavy lifting is performed by a registrar component. We think this is much better for decentralization and privacy and being in control of the identifiers. This is the approach that ideally should be used. And so next time we'll continue with our series. We'll look at additional ways how we can use deeds in interesting ways. And that's it. Thank you and goodbye.